Problem 3. Here we go. Diving in. All right, problem 3 says calculate the pH of the following solutions. These two solutions. The first one's a basic solution. How do you know? It's got OH. This one, acid. How do you know? It's got the H in front, and it's one of the strong acids you should know. Okay, you should know that. What's the pH? In the previous problem, we used this calculation to get the concentration of H or the concentration of OH. We didn't calculate the pH. Now we're going to take it a step further and use the pH equation. Okay. Sometimes we have to use this one or can use this one. Sometimes we don't. Sometimes we'll use both. It depends. All right, let's go ahead and see what I'm talking about. I'm actually going to do B first. B is a little easier to explain than A. A has this little nuance to it. Not hard, but we'll get back to it. Calculate the pH of the solution. Okay, so I have 5.2 times 10 to the negative fourth molar solution of HNO3. Bells and or whistles should be going off in your head because you know that HNO3 is a strong acid, and you know that when a strong acid deionizes, it does it 100%, meaning that every H comes off the NO3. So whatever my concentration is of the acid is my concentration of the hydrogen. And I need that concentration in the pH equation. All right, so let's go ahead and write this down, pH. How am I going to solve pH? The negative log times the concentration of H. If this is a strong acid, that is my H concentration. So 0.00052. 1, 2, 3, 4. Or you can write it out as 5.2 times 10 to the negative 4. Okay, either way, you'll get the same answer. So how do I do this? Okay, on my calculator, I'm going to take, you gotta have that log. I talked about that log button. You gotta have that log button. Yes, you do. So on this calculator, my TI 80 something, I hit log, and then it has a little flash saying, put something in, put something in. 0.00052. 0.00052. I'll close parenthesis on it. Okay. And I'm going to hit the log. I'm hit enter. I'm going to hit the log button. I'm hit enter, and it'll give me the that value for the log. Now, before I do that, I want to point something out. Logs are exponents. You don't have to know this, but logs are exponents, base 10 exponents. So the exponent here was 4. When I logify this, logification is a word, look it up. When I logify that, I should get an answer somewhere close to 4. Maybe 5, maybe 3, but that's it. Shouldn't be any more off than that. Now what's out in front will have an influence on it. If this were, it's not, but if this were 1 times 10 to the negative fourth, and I logified that, I'm going to get 4. Because logs are exponents. Now I'm not going to get 4, but I'll get close because of the 5.2 in front. All right, let's go. Drum roll. We've been drum rolling. Let's hit it. Hit enter. And what do we got? Ooh, look at that. Close to 4. Negative 3.28. Negative 3.28. So pH is equal to negative. All right, negative 3.28. It's negatives here. I can get rid of that negative. That's why it's here. So the pH is negative here, gets rid of that, is 3.28. Acidic, which makes sense. It's a strong acid, so it's got a nice low pH. Acidic pH, makes sense. All right, let's try A. That wasn't too bad, was it? Let's try A. Now, the only reason I didn't do A is because of the subscript 2. Barium hydroxide, is it a strong base? I don't know. You didn't give us a list of strong bases. I did not, but I told you that you have to be strong base. You have to have OH. All right, we got that going for us. And we have to have the metal out of group 1 and group 2. Barium's out of group 2. Boom, strong base. So what happens? You take this and put it in water. You will get a barium and two hydroxides. Yes. So that was a little tricky. So what happens? So this concentration, it's strong, so this concentration applies to this stuff. So that means I would have 2.8 times 10 to the negative fourth barium I'd have 2.8 times 10 to the negative fourth hydroxide and 2.8 times 10 to the negative fourth hydroxide. There are two of them, so it doubles the amount of hydroxide. So together, we double this. Don't double the exponent. You don't double the exponent. You just double the thing in front. So 2.8, double it, 5.6. So 5.6 times 10 to the negative 4. That's my concentration of hydroxide. Okay, now this didn't want hydroxide concentration, it wanted pH. How am I going for this, the pH? Two ways you could do it. You could take this, put it in here, divide it into 1 times 10 to the negative 14th, and get your H concentration, and take that, put it in here, answer. Or, since this is OH, we can get the POH of this solution. Remember in the last video, it might have been last video or 2 videos ago, we said, well, the other way you can get pH from POH is 14 minus. Yeah, if you have a pH or POH and you want the other one, take 14, okay, it's a scale, right? 0 to 14, and subtract either one of them, and it'll give you the other one. I'm going to do that second method. So let me show you that. Because we've done this method. I've done this method in the last video. We solve for that. We just take it one step further, take that, put it up here, and get the answer. I'm going to show you the other method. So 5.6 times 10 to the negative 14th. I've got to remember that number because I'm erasing it. Let's get the POH of the OH. Negative log 5.6 times 10 to the negative 4. All right, let's do it. Let's go ahead and hit the old calculator here, clear this out. We hit log, and then we hit 5.6 second function exponent negative 4. Logify that. All right, and I get negative 3.25. Okay, negative 3.25. So we're going to get rid of the negative because this negative cancels out the negative on the calculator. So the POH is 3.25. Now that's not the answer to the problem. It wants the pH, not the POH. So how do I get the pH? 14 minus 3.25. I will have the POH. I'll get the pH from the POH. So I just subtract those. I'm going to get 10.75. And that's my pH. All right? I like doing it that way. If you don't like doing it that way, or you don't believe me because I'm wearing a stupid shirt, then go ahead, take the 5.6 times 10 to the negative 4, put it here, divide that in here, get H, throw H up there, you get the same thing. Okay, this is a strong base. We should have a pH that's in the range of alkaline, which we do. 10 is above 7, makes sense. All right, so hope that makes some sense. Let me see here. We'll go ahead, we'll stop this video, keep these videos a little shorter, keep your attention span so you don't all fall asleep and start drooling on me. Well, you might be already. Wake up! All right, okay, see you soon.